Hello everybody and welcome. My name is Mr. Cantor and this is Modeling with Mr. Cantor. Now today we're going to be looking at Explore Part B. What I want you to do before we get started is to please pause this video and ask yourself, what do you notice and what do you wonder about what is in front of you? Alright, welcome back. Let's take a look at both of these tables and try to figure out what are some things that you notice and what are some things that you wonder. Let's start by reading this first. For the first table, it says, find the mean absolute deviation of Jada's data, rounded to the nearest tenth. They tell you the following numbers for Jada: 2, 4, 5, 4, 6, 6, 4, 7, 3, 4, 8, 7. Then it says distance from 5. I wonder what 5 is. Then it says Jada's MAD. I wonder what that is. Then it says find the absolute deviation of Lynn's data, rounded to the nearest tenth. Lynn's numbers are 3, 6, 6, 4, 5, 5, 3, 5, 4, 6, 6, 7. Distance from 5, and then it ends with Lynn's MAD. What could that mean? Please pause the video and let me know. What do you think distance from 5 represents? And what do you think Jada's MAD stands for and Lynn's MAD stands for? Alright, welcome back. If you said that distance from 5 is there because Jada's mean is 5, then you are correct. And when we're talking about Jada's MAD, if you said they're referring to Jada's mean absolute deviation, then you are correct. And when they are talking about Lynn's MAD, if you said that means Lynn's mean absolute deviation, you are also correct. All right, so with that said, let's get to it. We need to fill in this table. So please pause the video and let me know, how do you fill in this first table? All right, welcome back. If you said in order for you to calculate the distance from 5, we need to do some subtracting, then you are correct. Specifically, we need to take Jada's values in her table and subtract them from the number 5. In the event that 5 is greater than her data, we will put 5 first. And if 5 is less than her data, we will put 5 second. So with that said, let's get into more details as to what we are talking about here. So please pause this video and do your subtracting. All right, welcome back. If you did your subtracting correct, these are the values you should have gotten. 5 minus 2 is 3. 5 minus 4 is 1. 5 minus 5 is 0. 5 minus 4 is 1. Because 6 is greater than 5, we're going to start with 6. 6 minus 5 is 1. Again, 6 minus 5 is 1. Since the next number is 4 and 5 is greater, we're going to put 5 first. So 5 minus 4 is 1. Now we have 7 minus 5 is 2. 5 minus 3 is 2. 5 minus 4 is 1. 8 minus 5 is 3. And 7 minus 5 is 2. So with that said, they want us to calculate Jada's MAD. So why don't you pause this video, use the information in this table to calculate what is Jada's mean absolute deviation. All right, welcome back. If you took the following values 3, 1, 0, 1, 1, 1, 1, 2, 2, 1, 3, 2, and you added them all up, you should have gotten 18. And when you divide 18 by the amount of numbers that you just added, which is 12, you would have gotten 1.5. So this means that Jada's mean absolute deviation is 1.5. Not bad. Okay, let's talk about the next person. Let's talk about Lynn's data. Since you know how to find the distance from 5 from all of your values in the table, what I want you to do is to please pause this video and take the time to fill in the table yourself. Then we will look at your data and compare them. All right, welcome back. If you got 2, 1, 1, 1, 0, 0, 2, 0, 1, 1, 1, 2, you are correct. This is because 5 minus 3 is 2. 6 minus 5 is 1. 6 minus 5 is 1 again. 5 minus 4 is 1. 5 minus 5 is 0. 5 minus 5 is 0. 5 minus 3 is 2. 5 minus 5 is 0. 5 minus 4 is 1. 6 minus 5 is 1. 6 minus 5 is 1. And 7 minus 5 is 2. Good job. So with that said, I want you to pause the video one more time and look at all the data we have in this table and find the mean absolute deviation on your own. All right, welcome back. If you added all the numbers properly, you should have gotten 12. And since there are 12 numbers, when we find the average, we need to divide by 12. 12 divided by 12 is 1. This means that Lynn's mean absolute deviation is 1. Good job. All right, so with all this information done, let's take a look at what Explore Part C is requiring us to do. Now, what I want you to do is to please pause this video. Look at the information provided to you, think about it, let me know what you think, and then we will look at it together. All right, welcome back. Let's take a look at the story. It says, compare the MADs, or the mean absolute deviations, and the dot plots of the 3 students' data. Do you see a relationship between each student's MAD and the distribution on her dot plot? Explain your reasoning. Okay, so we have Elena's dot plot, we have Lynn's dot plot, and we have Jada's dot plot. Pause the video, let me know, what do you notice and what do you wonder about these 3 dot plots? All right, welcome back. You might have noticed that Elena's dot plot, the numbers are much further apart. You might have noticed that Lynn's dot plot, the numbers are kind of close together and more compact. And for Jada, you might have noticed the numbers are somewhat spaced out, but also somewhat compact. Okay, so with that out the way, let's actually answer the question. Please pause the video. What do you think? Do you see a relationship between each student's MAD and the distribution of their dot plots? All right, welcome back. If you said, yes, I see a relationship between the MAD and the distribution of data. The largest MAD value corresponds to the dot plot with the widest spread. The smallest MAD value corresponds to the dot plot with the narrowest spread. And remember, this is just one of the ways that you may answer this question, but there are a lot of different variations to how you can say this answer correctly. As long as you are leading on to the point that the greater someone's MAD is, the more further spaced the data points will be. And the smaller somebody's MAD is, the closer the data points will be. With that said, my name is Mr. Cantor. Thank you so much for watching this video. I will see you in the next one. Take care for now.